Ever wonder what's actually happening inside your phone in that split second between when you tap on an app and poof, it loads? It's not magic, I promise. It's actually a lightning-fast, totally invisible conversation happening between your phone and the 5G network. And today, we're going to pull back the curtain on that entire conversation, from the very first hello your phone sends out to how it keeps you connected while you're driving down the freeway. We are going to break down the fundamentals of 5G call processing. More specifically, we're diving deep into what makes true 5G really tick: standalone mode. This is the end game for carriers. We're talking about a pure end-to-end 5G experience that doesn't rely on any of the older 4G infrastructure at all. Okay, let's get into it. Here's our roadmap for today. We're going to start with that very first handshake. Open up the data tab, talk about data highways, look at how your phone saves power, and finally, see how you stay connected on the move. First things first, let's talk about the most fundamental step of all. How does your phone go from being, just a silent brick in your pocket to being recognized and actually allowed onto the 5G network? So really think about it for a second. You hit that power button, the screen lights up, but before you can do anything online, your phone has to introduce itself. So how does it do that? What's that first move? It all happens in this incredibly fast three-step dance. First, it scans the air, listening for any 5G signals in your area. Then, it locks onto the strongest one and acquires what's called system info. Think of this like downloading the basic rules of the road for that specific network, which are in these little messages called the MIB and SIB1. Finally, once it knows the rules, it starts the registration, basically raising its hand and saying, "Hey, I'm here. Can I please connect?" The best way to think about this whole registration thing is like a passport check at the border. The network looks at your phone's credentials, verifies that you're a real subscriber, and then officially stamps your passport, granting you access. If you don't pass this check, you're not getting in. Simple as that.
Okay, so our passport is stamped, we're officially on the network. But that's just step one. Now we need to actually get connected to the internet so our apps can, work.
And we do this by establishing something called a PDU session. Now I know, it sounds super technical, but just think of it as your own personal secure data pipeline. It's the tunnel that connects your phone through the 5G network all the way to the big wide internet. No PDU session means no data connection. Let's use another analogy to make it stick. If that first registration step was like checking into a hotel and getting your room key, establishing a PDU session is like getting the specific Wi-Fi password for your room. You're in the building, but now you have what you need to actually get online. All right, you're connected. But 5G isn't just about one big connection. It's about being incredibly smart and managing lots of different types of connections all at once. And this is where one of its most powerful, game-changing features comes into play. It's this awesome concept called network slicing. Okay, imagine the entire 5G network is one massive superhighway. Slicing lets the network operators create dedicated virtual VIP lanes on that exact same highway. Each lane is totally separate and optimized for a very specific kind of traffic. And this is where it gets really cool. You could have one slice that's a high-speed express lane, perfect for streaming 4K movies without a single hiccup. At the same time, there's another slice that's an ultra-reliable, low-latency lane for something super critical, like a self-driving car that needs instant response times. And then a third slice could be a massive low-power lane designed to connect millions of simple little sensors. They all exist on the same network, at the same time, without messing with each other. So, who manages all these different lanes? Well, that's where quality of service, or QoS, comes in. Think of QoS as the traffic manager for the whole highway. It enforces the rules for each slice, making absolutely sure that the data for that autonomous car gets top priority over, say, a background app update. Now, all this incredible performance is great, but you're probably thinking, what about my battery life? Well, let's look at how 5G pulls off this masterful balancing act between high performance and power saving. Here's the secret. Your phone's connection isn't just on. That would be way too simple. It's actually constantly and intelligently jumping between three different connection states. We call them RRC states, to save as much juice as possible without you ever noticing a thing. And this table just lays it out perfectly. When you're actively scrolling or streaming a video, you're in RRC connected. Yeah, it's high power, but your data is instantaneous. The second you put your phone down, it drops to RRC inactive, low power, but it's ready to wake up in a flash for a notification. And after it's been asleep for a while, it goes into RRC idle, sipping the absolute bare minimum of battery. It's this non-stop, invisible dance to give you performance when you need it and battery life when you don't.
Okay, last part of our journey. Let's cover the magic that keeps you connected when you're not standing still, and how 5G handles something as basic as, well, a phone call.
This is all about mobility, or to be more specific, a handover. As you're walking or driving, your phone is constantly measuring the signal strength from all the cell towers around you. Just before the signal from your current tower gets too weak, it performs a totally seamless handover to a stronger one. It happens so fast and so smoothly that your video stream never buffers and your call never ever drops. So when it comes to an actual voice call, 5G has two main strategies. The gold standard is called VoNR, which stands for Voice over New Radio. This is a true native 5G call with amazing audio quality. But if that 5G signal isn't quite strong enough, your phone has a built-in safety net called EPS fallback. It just seamlessly drops the call down to the super reliable 4G network just for the length of your call, making sure it stays crystal clear. So there you have it. From that initial passport check to opening the data tap, managing traffic on virtual highways, intelligently saving your battery, and keeping you connected on the go. That, right there, is the complete life cycle of a 5G standalone connection.
It's a seriously sophisticated system, designed from the ground up to be crazy powerful and incredibly efficient. Which, of course, leaves us with one giant question. With a foundation this flexible and this capable, what in the world are we going to build on top of it next?